5.2, Properties of Rational Exponents and Radicals, page 244 through 247 in your textbook, Properties of Radical Exponents. Now, we have already talked about the properties of radical exponents in 5.0. These are the same. All they've really done with these is kind of up the level of difficulty. So I'm not going to go over really all of them again, but, real quickly. If I'm multiplying like bases, you add your exponents. If I have a power, you multiply your exponents. If you have like a power outside of multiple terms, you distribute that power into all of them. Any negative exponent is really not a negative number. It's a really small number, so we write it as a fraction. Any exponent of a 0 is equal to 1, except 0. And then the quotient probably, if you're dividing like bases, you subtract your exponents. And then again, if you have a division and an exponent, you basically distribute it to top and bottom, numerator and denominator. Look at those examples. They're really good examples to look at, just to kind of familiarize yourself. I'm going to go ahead and start showing you them. So, here we go. Use the properties of radical exponents to simplify the expression. Okay, so here we go. Number 1, I have 7 to the 1/4 power times 7 to the 1/2 power. And since I have like bases, I add my exponents. So that equals 7 to the 1/4 power plus 1/2 power. Now what do we know? Well, in order to add fractions, we must have common denominators. So we need to multiply 2 to both top and bottom. And that will give me 7 to the 1/4 power plus 2/4. And now I have like denominators. I can combine my numerators. 1 and 2 is 3. Common denominator is 4. And you get 7 to the 3/4 power. Done. Next one. I got this power of a power, really. So I'm really distributing that 2 to both those terms. So I now have 6 to the 2's power, or 2 over 2, which is just 1. And then 4 to the 2/3 power. Alright, so now really if I simplify that, I get 6 times 4 to the 2/3 power. And that is it. That's as far as I need to go on that one. Next. Same idea. Distribute. This one has a negative though, so I'm going to first do this. I'm going to do let's distribute. So I get 4 to the negative 5/5 power times 3 to the negative 5/5 power. And again, those are 1s really, so it's like 1 over 4 to the 1st power times 3 to the 1st power. And now that's 1 over 12. Again, negatives are not negative numbers, they're just really small numbers, so we write them as fractions. Okay, next one. 125, really, it's to the 1st power, right? Over 125 to the 3rd power. So I'm just going to change that 1 to 3/3. That way I have common denominators. And if I have common denominators, I subtract my exponents. So when I do that, I get 125 to the 3 minus 2/3 power. And now I get 125 to the 1/3 power. I'm sorry, that should be 1. So it should be 2/3 power. Hard to see. Getting old. Alright, and then here you go. Last one here. Again, I'm going to basically distribute this into both of those. There's a couple of ways I could go about this one. But I get 48 to the 2/3 power over 6 to the 2/3 power. And basically, since they're both to the 2/3 power, I can make it 48 over 6, all of that to the 2/3 power. All right, kind of go backwards a little bit. And 48 divided by 6 is 7. and that's to the 2/3 power, and I can't simplify that, and I'm good to go. That's it. Okay, so using these powers or these properties of exponents, go ahead and continue on to do number 2. Pause now because I'm going to go ahead and show the answers. Here you go. Okay, there are our answers. Hopefully you got those correct. Take a look longer if you need. By pausing it, I'm going to keep on moving forward here. So, if I scoot on down, properties of radicals. Alright, so the product property basically is if I have the nth root of a times b, that equals to the nth root of a times the nth root of b. Okay, and for example, the cube root of 4 times the cube root of 2 is equal to the cube root of 8, which would then be 2. And then the quotient property is the nth root of a divided by b is equal to the nth root of a divided by the nth root of b. Alright, so basically those work vice versa. Can't really see. The 4th root of 162 divided by the 4th root of 2 is equal to the 4th root of 162 divided by 2. Which actually I kind of maybe even showed a little bit. Oh, not with an nth root. Never mind. And then the 4th root of 81 is 3 if we continue on with that. Alright, so I'm going to keep on going. Let's flip that up here. Number 3, using properties of radicals. Okay, so when I have something like this, I got the cube root of 12 and the cube root of 18. They are not the same. So what I would do is look to simplify. And when I do my factor tree of 12, I'd say 4 times 3. And I always, cube root 2 and 2. And then if I look at 18, I'd maybe say 9 and 2 and 3 and 3. And now what I'm looking for is groups of 3, right? So I got 1, 2, 3 2s, so I can pull out that 2. Alright, I have 1, 2, 3 3s. Pull out that 3, and what is 2 times 3? 6, and that's my answer. Nothing left under the radical. Perfect cubes. Okay. Another way I could have gone about that, if you really wanted, is I could take those two and multiply, so I get the cube root of 12 times 18, which is the cube root of 216, which is 6. So that's another way I could have gone about that problem. I prefer this, but either way. Alright, next. This one, I get the 4th root of 80 over the 4th root of 5. And again, here's where I'd change this. I'd go the 4th root of 80 over 5. And what's 80 divided by 5? Well, it's 16. So I get the 4th root of 16, and that is going to give me 2. And since, again, I really have that even, right, I can make it positive and negative 2. So, positive, negative 2 there. Alright. What I'm going to go ahead and do is show you the answer here for number 4. So give it a try. Pause it now because I'm going to show those answers. Here they are. It is 8 and 2. 8 and 2 are your answers. Okay, I'm going to keep on pushing forward. Alright, so here I have radicals in simplest form. So this time, we may have a root. That's usually what that means. So we and I go ahead and do this. I'm looking again for groups of 3. And I'm going to factor 135, and that would be 5 times 27, which would be 3 times 9, and 3 times 3. Again, looking for groups of 3, I have 3 3s. Okay, I pull that out. Right? And what's left? That root 5, so it's 3 cubed root 5, and that is it. That's my answer. Done. Over here for B. same idea. I got, okay, so this one's actually a tad different. Couple different ways you can go about it. I'm going to actually do this. I'm going to make it the fifth root of 7/8. But I need to make this new denominator here without the radical. I need it to be SRF form, simplest radical form. And if I have a radical in my denominator, it's no longer simplest radical form. So in order for me to do that, this is 2 cubed. If I multiply it by 4, that would make that radical go away, because 2 to the 5th power, 5th root of that, basically knocks it out. So now that is equal to the 5th root of 28/32. And again, the cube, let's go this way. The 5th root of 28 over the 5th root of 32. And I do have 5 2's here, sorry. So when I continue this problem, I'm going to just write here, the 5th root of 28 stays there. I don't have 5 of a kind there, but I do have 5 2's here, so I can pull out the 2. Okay. Real quick. 16 times 2, 2 times 8, 4 times 2, and 2 times 2. 1, 2, 3, 4, 5. 5 2's. Alright. Here you go. Go ahead and do number 6, A and B. I'm going to go ahead and pause to show you this. So pause now. So here are the answers. Right here. So the answers are 5 cube root 4 and the 4th root of 76 over 2. Pause that if you need more time with it, because I'm going to continue to go on. We got more skills, a bunch of skills in this section, so here we go. Number 7. Alright, it says write a radical expression in simplest form. Alright, so it says write the 2 over 5 plus the root of 3 in simplest form. And this is the conjugate. Alright, this is a conjugate that we talked about before. We've got to get rid of that conjugate. So if I have this 2 over 5 plus root 3, what you want to do is you're going to multiply by 5 minus root 3 to both top and bottom. Okay, so when I do that, on the top I get 10 minus 2 root 3. On the bottom, 5 times 5 is, and I'm just foiling here. First, 5 times 5 is 25, and then 5 times negative root 3, 5 minus 5 root 3, root 3 times 5 plus 5 root 3. And what do we know there? Those are going to cancel out. And then root 3 times root 3, or root 3 times negative root 3 is negative 3. Okay, so now I combine 25 minus 3, and that's 22, so I get 10 minus 2 root 3 over 22. And I actually can simplify this even more, because I can pull out that 2, what I initially had, which I kind of wish I didn't multiply it back in right now, but now I can simplify that, make that 11, and there is my final answer. 5 minus root 3 all over 11. Okay, I'm going to go ahead and stop this one, but I'll come back and show you this answer. So go ahead and give number 8 a try.